Hey everyone, welcome to the Latent Space Podcast. This is Alessio, partner and CTO at Decibel, and enjoy my Wicks, founder of Small AI.
Hello, and this is another one of our really short sort of news-based episodes that we're trying out to do, and it's with Mahesh and team from Bespoke Labs. Welcome.
Thank you. Yeah, thank you.
Maybe we'll go one by one and identify voices. So Mahesh, Ryan, and Trung, you want to go and who you are, what you do. Yeah.
Sure. Yes. Hey guys, thanks for inviting us. My name is Mahesh, and I'm co-founder and CEO of Bespoke Labs. And I'm here with Ryan and Trung, who are our founding engineers. Ryan, you want to go next?
Yeah, sure. So I'm Ryan, I'm founding engineer at Bespoke. I'm also an AI researcher. We collaborate with this group of Datacomp, and yes.
Is that Datacomp? Is that Datacomp LM or the image Datacomp?
Yes. So I was actually part of the original image Datacomp, which was text and images. And then there was one about language models, which was pre-training. And now we're looking into fine-tuning.
Nice. Yeah, I actually interviewed both the original Datacomp and the new Datacomp LM team at Europe. So that was fun. Trung, go ahead.
Hi, I'm Trung, a founding engineer at Bespoke Labs. And yeah, I work on Curator, which is our data curation library. Please start it. And then also Datacomp. Yeah.
Yeah, so, okay, we're meeting to talk about what happened after DeepSeek's launch. You guys had a crazy 48 hours, is what I understand.
Yes.
Distilling DeepSeek into Qwen and basically beating O1 preview. That's my TLDR. Obviously, there's more to it. Basically, can somebody summarize what happened for someone who only knows about O1 and DeepSeek?
Sure. Yeah, I think I can give I can set this up, right? So actually at Bespoke Labs, we were building this thing called Curator, which makes it easy to curate data. And a big part of it is helping with distillation, right? So we literally announced it last Wednesday. And so the timing was perfect. So on Monday, when Monday morning DeepSeek R1 was released, we were thinking, okay, maybe we can use Curator. We were trying to think through this to say, okay, should we do this? Not. SkyT1 had released a distilled model, which was using QWQ. And we were thinking, okay, maybe with DeepSeek R1, we can also do a distillation. And around 5 p.m. is when we were like, okay, let's just start this. And since Curator it's really well built. So it took us 5 minutes or so to set things up. And within 1.5 hours, the data was almost ready. So after that, things were okay, let's just do this, see this through. And yeah, Ryan and Trung were working effortlessly and basically putting light outs. And we started that. We went through and did the verification of data and started training run that same night. And, within next morning, we started to see that the results are starting to look pretty good. Oh yeah, so basically within 48 hours, we were able to get the data, verify it, train a model, eval, and announce it on Wednesday morning. So that's the background. I can talk more. Yeah, anything else to add, Ryan and Trung?
I think that pretty much covers it.
Yeah.
It was a pretty crazy sprint. It was pretty exciting, right? SkyT1 was really, really interesting because at least personally, I was like, okay, these reasoning models are really cool. There's rumors about how they're built. It seems like it's pretty hard. And then it turns out that you can actually just use another existing reasoning model to answer questions. And it generates those really long responses where it's sort of rambling on chain of thought reasoning traces. And then you can just take those and use a very basic training procedure, post-training procedure, supervised fine-tuning, and take an instruct model and then get a pretty decent reasoning model. So that was very exciting, right? We saw SkyT1 release that, and we were thinking about it. And then what we actually have seen is that the annotator for synthetic data is really, really important. So when we saw DeepSeek R1 came out and you have access to it, we were really excited because now you have the supercharged teacher annotator model that you can just plug right into the SkyT1 data pipeline, which is phenomenal, and then basically churn out great results.
Before we jump in, can we just do a little bit of glossary, so to speak? So I think when people say distill model, I think people have different understanding. So one is I'm taking one model, I'm making data, I'm retraining another model on the data. Some people are using it for fine tuning. Some people are just using the data. They're not using the logits. Some people are using the logits. Can you just run through your explanation of the process and maybe just explain some of these terms so that then people have them in mind?
Yeah, I can actually start with I think around 2016 or so, there was this paper on distillation. Geoffrey Hinton wrote this paper on, the idea was like, okay, you train one larger model and then look at the logics that it produces and try to have a smaller model mimic those logics. So that's how distillation started, was on the logic level, right? So there is some sort of dark knowledge that is encoded in distillation or in this teacher model, which is actually helpful for the student model. So as a rough example, you are trying to do a image classification, you can just tell the model, okay, this image is a car or a cheetah or something like that. Whereas when you're doing distillation, what happens is like the teacher model can actually give you some confidence scores, right? Like a car and a truck are somewhat similar. So the logics are correspondingly, there is some non-trivial value for a truck. Whereas for cheetah or something like that, it's zero. So that's dark knowledge. That's how people started doing distillation. And now, and I guess, yeah, sometime back, what distillation became is like you have a teacher model, like a much larger LLM, that's basically generating data. So that's at the data level. And then once you have the data, you fine tune. And now I think also now people are starting to see like, how do we combine both fine tuning on the data that the teacher produced, but also looking at the actual logics that the teacher was using. So that's the third level. So what we did was the second one, which is just take the data that the teacher produced. And it's basically a way of curating data, right? Humans could have written those data, but it's just way more expensive and time consuming. So now we have a very good teacher or a very good LLM writing it. So that's distillation. So that, yeah.
And then just to keep digging on that, a lot of this on the reasoning side you can do now because, of course, O1 doesn't show the reasoning traces. So part of it is also that the open models, like I think maybe before the discussion was like, is the data that you get from Llama 3, 4, or 5B that much worse than like 4? And I think now with O1, you just cannot get reasoning traces at all. So with R1, it's the first time we actually get the reasoning traces in open source. And maybe you guys can run people through how that data looks different than traditional check completions, like any particular work you have to do it to curate it. Like, is the process the same? I know, you have a whole company that is focused on helping people curate data for fine tuning. So I'm sure you have a lot of stories.
And on Trung, do you guys want to take this?
Well, I think just one thing that's interesting you said there is that the O1 reasoning traces aren't available. And I think we're seeing why, right? The title of our release was called The Unreasonable Effectiveness of Reasoning Distillation, right? It's really surprising just how easy it is and how well it works. So OpenAI doesn't want to give that out for free. In terms of the actual data, yes, the data is very different, right? The responses are much, much, much longer, right? We're using much more inference. And also the style of the response is much different. Rather than a direct answer, which is easy to read, you get these walls of text, right? So there is a difference, right? In terms of the sort of things that you can do with the reasoning trace can be more interesting. So you can rewrite it and reformat it in different ways, right? And I think this is something that people are exploring. We're exploring too. And generally, some of the lessons learned from generating synthetic data previously when you're just doing instruction tuning, these lessons can be applied, but there's also new ground here, which is really exciting.
And the other thing is like other interesting thing. So chain of thought has always been there, but sometimes when you have a tricky problem, what you are doing is you want to be able to backtrack and kind of search through the answer. Initially, when O1 came out, people thought, okay, maybe there is some fancy search happening where the model, emits some step, and then you go back and so on. But later on, what it turns out is it's happening just through the reasoning steps. Is like the model is like taking some steps and then says, okay, it's just literally backtracking, right? Okay, this is probably not right. And in the next step, it says, okay, we should try something else. So it's just auto-regressive decoding. It's just many steps of reasoning where there is implicit search and backtracking happening all through those reasoning steps. So that's kind of what makes it very powerful.
Yeah, I cannot tell you guys how shocking this was when we were discussing this in the company Slack, because we thought, we need all these this very complicated search technology. So in search, you would need kind of like a driver algorithm that does the search, that tells the model to go down these branches and go up and do all these things. And then the model kind of generates stuff, and then the search algorithm kind of drives that. But what what's like really, really impressive and really, really surprising about R1, as things are coming out, is that you literally just train the model to solve this math problems, and the model automatically learns the search algorithm. I don't know if you guys have heard of the bitter lesson, right? There are two things that work in AI, like learning and search. And it turns out you just need learning because you can learn to search. So to me, that was a big revelation that all of these emergent properties can emerge out of just doing like, reinforcement learning on outcomes.
So I want to push back a little bit.
Yeah.
Mostly I agree on this discussion, especially from the R1 paper. R1 specifically said, yes, we tried MCTS. Yes, we tried PRMs, and none of that is useful.
Yes.
Okay. But there's a question of whether or not the name Q star was a psyop. It just like threw us off for a whole year because they were like, oh my God, they're doing search because they said Q star. And it turns out they don't do search. I think there might be a different distinction between, yes, you can have autoregressive distillation of this reasoning paths, including backtracking for the distilled models. But maybe the full-size models are different, right? Like the only way you reach the frontier with the full-size models of O1 and O3 is with that stuff. And then you can distill to the minis, the O1 mini, O3 mini. So in my write-up, I said, like, maybe this is the formula for O1 mini, O3 mini. This is why they're cheaper.
Right. So there is training. You can do all sorts of search during training, meaning at least to generate training data, right? So that is there. And of course, for O1,
yes.
All of
inference time. Yeah, even O3 inference time may not be doing search, right? Yeah, this is something that people are speculating.
Right. Yeah, there's yes, we don't know the answers to this. Yes, that's why it's actually very interesting. Yeah.
Okay. Yeah, and I think the other thing as well I wanted to discuss with you was generalization. And the idea that a lot of people were thinking about was, okay, we can only write verifiers for code and math, so this will only be good in code and math.
Yeah.
It seems like at least R1 is generalizing very well. I don't know. I haven't looked through your 17,000 rows, but I assume it's mostly code and math. Are you finding that it's generalizing well?
Right. This model is trained for those. It's reasoning benchmarks and reasoning tasks. So it's pretty much, code, math, those kind of questions. Yes, I don't think it will be a very good model to write poetry. So it may not.
I think that you can do that, right? So if you look at how some of DeepSeek's distilled models are trained, they have 800K instances for SFT. 600K of those are reasoning and 200K are non-reasoning. So yes, this is a very interesting question. What is the right data mix to retain the general abilities of a chat model? This is not something that we looked at with the bespoke Stratos 32B release, but this is something that we're looking at. And I think that the answer to this will be interesting for everyone, as DeepSeek did not release their data, unfortunately.
The natural question is actually, so you did 17K because SkyT1 did 17K, correct?
Yeah.
Do you think that you'll get the same results if you just went to 800K rows? Or do you think that DeepSeek has other secrets?
Well, so that's actively what we are, planning to work on, is like figuring out the data curation strategy to improve these models, right? So our hope is, we don't have to actually get to 8K, but somewhere in between. So basically the quality of data matters a lot. That's something that's abundantly clear, because compared to SkyT1, the new data is better because R1 is better model. We just want to make sure we can curate it in such a way that we can get a very good data, make sure that gets us to the level of what they were able to distill, or hopefully meet them.
Yeah. To answer your question, yes, but more data should improve here, right? So this is something that we're looking at. The question is, how much will it improve? And then
how much
do you need?
Yeah. I'm interested in a chart. You should sort of do an ablation of like every 10K, every 100K, obviously you're going to...
That'd be a
cool chart.
The chart is cooking.
The chart is coming.
The Pareto frontier, right? The Pareto curve, like the model size versus, it looks like smaller models need a lot more data. So that's something also that will be interesting.
Yeah,
that's actually something that was actually pretty interesting here, right? Is this the SkyT1 release? They released a 32B model. And they said, actually, they did not see improvements on the 7B model, right? So there was a big question of, can you even do this on 7B models with SFT? And then DeepSeek R1 paper came out, and they had great distills, right? They had even 1.5B. It was insane. And it was super cool to see. And the answer is obviously like, yes, you can do it. So we also released bespoke Stratos 7B. which improved from the model it was trained on, which was Quen 2.5 in the instruct, not as much as the 2B model, and obviously not at the level of performance of the 32B model. But it's interesting and it's inspiring, right? Like it seems like you can also do this at the smaller scale, and I think that's pretty interesting.
Yeah, agreed. Sorry, what did you do differently that your 7B worked and their 7B didn't?
Yeah, this is a great question. It seems like the data quality, right? The simple thing that we changed is changing out quick QWQ for DeepSeek R1. So the data is just better. We did do some tweaks to the data pipeline, which Trung can talk about more. Maybe those help significantly, but it seems like just the better teacher is the major factor. We could, we can also ablate these decisions as well. Yeah, Trung, why don't you tell a little bit more?
Yeah, I think like we know that I think we, based on just looking at the traces, we see that the R1 traces are more coherent than the quick traces. So we can see this because when we look at the traces from the SkyT1 dataset, a lot of the time the model is like, given an answer about math, and it starts like, let's think about marine biology, let's think about like forestry, let's think about all these other things. And then like finally it gets to the topic of math. In R1, we see that the model behaves much more coherently. One interesting thing, we did a couple changes in the pipeline. One very interesting thing is that in the original SkyT1 pipeline, they needed to rewrite the reasoning traces from quick to improve coherence because the model is rambling so much from what we see. With R1, I think it's such a high quality reasoning model that we found that we didn't need to do it when we read the traces, and we just decided to we looked at the traces and say, this looks really good. Like let's just do this, and I think like that shows in the metrics. There are other.
You just remove the step where you use.
We ablated the re-annotation. Sorry, of the original SkyT1 pipeline. So immediately we can see that the quality improvement is pretty significant.
But
just
we
based
did
on eyeballing.
Yeah, so we did do some filtering, right?
Yes, we so there are two things. Like first, like there's some filtering to make sure, like given a math problem that you have ground truth solutions on, filtering so that the answer provided by R1 or quick is the correct answer based on the ground truth solution. So that's very basic, like correctness, rejection sampling, right? You just filter for correctness. The other thing, which I wouldn't call it a filtering step, is like the re-annotation step from the SkyT1 pipeline, which rewrites the original quick traces into something that's much more readable and easier to parse using GPT-4 So the one that we did not ablate this rejection sampling, and we've been discussing internally, maybe that's not even necessary given how good R1 is. But the thing that we did ablate, given like the quality of the R1 reasoning traces, is the annotation step.
Got it. Well, thank you for doing that. That's actually very, very comprehensive. One short question and a longer question. The short question is, do you ever see a path where the students become smarter than the teacher?
We had. There is one other example, right? For the mini-check model, we have trained a 7B model. And
maybe you want to introduce the mini-check model.
Yes.
I know about it, but...
Right. So sometime back in August or so, we released a model called Bespoke Mini-check. And what it does is it's in the text setting. It takes a context, for example, a paragraph and a claim, and it tells you whether this claim is supported or grounded in this paragraph or not. It's very useful in RAG to prevent hallucination, right? So the main point, the main point I'm getting to is like for that particular model, it's a 7B model, and the data comes from 405B, Llama 5B, and we were able to beat the Llama 405B on that particular data. So just by doing some of the data munging, basically, I call it inductive prior. So you introduce like how to organize the data, and that will actually help you beat the teacher, right? So I think, yes, to short answer, yes, I think we can do it. But of course, it depends on case by case basis and what kind of settings we are doing, right? So that's,
I think we have to. Yeah. We're getting to this stage where we have to figure out how to make the student smarter than the teacher. And then, okay, like other reasoning work that you are interested in. For me, this was kind of obvious because I read the STAR paper, self-taught reasoning. And it made sense. And then we also, on this podcast, we interviewed Cosine that actually fine-tuned 4.0 on SweetBench, to achieve state-of-the-art on SweetBench. And that score was actually higher than O1 when it came out. And that was my first clue that, you can actually take autoregressive models and just give reasoning data and it still outperforms reasoning models. And I mean, now we're seeing this come to life here. But like basically like related work, like papers you recommend or other things you're watching that you think will be relevant this year.
Yeah, I think this great debate about so of course, one is the role of RL, right? Like DeepSeek, they in fact said that at least for one of their R10 models, like they didn't even do SFT on it. So that's very interesting, right? To improve reasoning, we did like a lot of SFT and it does really well. They have a new recipe where they don't do any SFT, just RL. So that's something I think people have to study, and like, there is a lot of work that's going to happen this year. So that I think that's something that I'm quite excited about. And yeah, in general, the other thing would be like for inference time scaling, how does inference time scaling, like I was definitely under the impression, okay, we will do some more search during inference time. Maybe it's not happening. So, but I think there is still a role for that to be, for that to happen. So that's the other thing that I'm quite excited about.
Anyone else?
I mean, we might just, we get surprises like every week. So just hold on for the ride, right?
Hold on to your papers, as they say.
Yes.
And yeah,
anything else that we should have asked? Anything else that you should have asked that you're just excited about, or just in the sort of bespoke
right
model that we didn't ask?
For no, I think just the fact that data quality matters a lot, right? So it's actually what our bet is also is like a data curation and curating high quality data. So basically there are three things we need to look into. People have an idea and they want to fine tune model, but typically they fail in the data curation stage. So that's something that we want really to help people with. And there predominantly you want to tackle like quantity of data, get good lot of data, and quality and diversity. So there are these three axes of how to think through data curation. So in this work, we fixed, I guess, quantity. We improved on the quality. So there is more work to be done on these different axes. Yeah, the shape of product we are building, we are hoping that this actually, with the curator, that the product we are building called Curator, hopefully helps people to kind of turn the knobs on all three of these and get good quality data and therefore good quality models.
Awesome. Yeah, I think to underscore that, we're really interested in what data recipes work and building tools that make it really, really easy to use those recipes.
Yeah. And also just one more thing is, we are now working very closely with the Datacom team and a lot of great researchers there, and hoping to produce some good work along these steps now.
Yeah. And is there any juice left in the synthetic textbooks stuff, or is that done already? Is that last year's?
Oh, synthetic textbooks?
Yeah. FineWeb EDU.
Yeah.
Yeah.
I think, just the data quality matters, right? So it's just textbook is a form of, data and high quality data. I don't know. Yeah, we are not looking into that kind of stuff, but, we are building
more
a platform.
Reasoning.
Yeah, reasoning.
So Datacom RM coming. Okay. Alessio, right. Anything else? Yeah.
No, this was great. I mean, it's amazing to see how, since this R1 model came out every 3 hours or something. So thank you guys for jumping on short notice, and great work.
Yeah,
thanks guys. This was fun.
Hosting us. Yeah, thank
you.